We are going to try something a little bit different. We're going to do what's called a flipped class. So the way this is going to work is I'm going to be making these videos for you, and you will watch these videos at home and fill in your note sheet. And then when you come to class, you will be prepared for what we're going to do in class the next day. So we're going to start with Chapter 18, Section 2. This is the gas laws. We've done Section 1 and Section 3 on states of matter and phase changes. And now we're going to focus on gases and how we measure gases and what that looks like. So when we talk about gases, we have to look at three things. We have to look at volume, temperature, and pressure, all right? And we know about volume and temperature. We know that volume is the amount of space something fills. We know that temperature is the measure of the average kinetic energy of the particles of a substance. Remember, we talked about the difference between heat and temperature in the last unit. We said that heat was the energy from the motion of the particles in a substance, so that kinetic energy of the particles in a substance, and then temperature is the measurement of that energy. So remember the difference between temperature and heat, all right? So for volume, we know our units of measurement, and for temperature, we know our units of measurement, which would be degrees Celsius or Kelvin. We will be using Kelvin instead of degrees Celsius, so I want to refresh your memory on how we convert Celsius to Kelvin. So to do that, Kelvin is equal to our degrees Celsius plus 273. All right, so for example, let's say we had a substance that was measured 20 degrees Celsius. To turn that into Kelvin, we would add 273, of course we'd get 293, and our unit of measurement would be Kelvin. Now notice that I did not say 293 degrees Kelvin, it's just Kelvin, all right? So your degrees Celsius plus 273 would get you to Kelvin, and then if you had to convert from Kelvin back to Celsius, you take your Kelvin number and subtract 273 to get your degrees Celsius. All right, so let's talk about what pressure is, because we haven't really talked about pressure yet. Okay, so if you look at the definition of pressure, force of the outward push divided by the area of the walls on the container. All right, so let's just imagine you've got a container here that is full of, maybe, technology is great when it works, that is full of particles. All right, hopefully this won't let me finish doing that. Full of particles, there we go. All right, so let's say we've got these little particles kind of all over, right? So we've got all these gas particles, and this container has a lid on it, right? And so the particles that are in here are moving around, and so they're going to be bouncing off the walls, maybe hitting each other, and they are constantly moving around, all right? So as they're moving around, they're pushing on the sides of the container, and as they're pushing on the sides of the container, they're exerting pressure. So that's how we have pressure. It's that push on the sides of the container. And of course, you know, if we do something like add heat to it, then of course those particles are going to be moving faster, and there's going to be more pressure, and so on and so forth. Okay? The other thing I want you to notice about pressure is our units of measurement. There's several units of measurement for pressure, but we're going to focus on these three. We have ATMs, which is for atmospheres, kPa is our kilopascals, and mmHg is millimeters of mercury. You don't necessarily have to know that, what each of those stands for, but you do have to be able to recognize that if there's a number that has one of these units of measurement, you need to know that that number represents pressure. All right? Now, the first law we're going to talk about is called Boyles Law. Boyle is the name of the scientist who figured this out. And Boyle figured out that if you increase pressure, then volume is going to decrease, or if you decrease the pressure, the volume is going to increase, and all this happens at a constant temperature. So remember, we said that when we talk about gases, we have to consider pressure, volume, and temperature. And we have all three of these in there. We've got temperature, pressure, and volume. All right? But because temperature is constant, we kind of don't have to worry about it because it's not going to change. All right? So if you notice in our formula, we've got P1V1 equals P2V2. Notice that there's no temperature in the formula. That's because the temperature is constant. All right, so P1 is our original pressure. V1 is our original volume. All right, and then P2, V2 are our ending pressure and volume. Okay, so that's our formula. All right, so let's look at this. Here's an example. All right, so in here we've got our container that has 1 liter of volume and it has 100 millimeters of mercury of pressure. So look at our particles. They're moving, they're kind of bouncing around, and you know, they're just doing what they do. But notice if we increase the pressure, so we've increased our pressure, look what's happening to the particles. They're moving much faster. They're doing more bouncing around, all right? And our volume has decreased, all right? So just like Boyle's Law says, if you increase pressure, the volume is going to decrease. And you can see that our particles are moving around because we have a decreased volume and an increased pressure, all right? So what type of relationship do pressure and volume have in Boyle's Law? It is inversely proportional, or we would say there's an inverse relationship. All right? One goes up, the other goes down. Pressure goes up, volume goes down, volume goes up, pressure goes down, and vice versa. All right? So let's do an example of a problem. Okay? So here we have a balloon has a volume of 1 liter at a pressure of 500 kilopascals. What is the new pressure if the balloon is changed so that the volume is 0.3 liters. All right, so the easiest way to do this is let's just make sure that we know what each of these, our pressure and our volumes are. All right, so our initial pressure is 500 kilopascals. Our initial volume is 1 liter, okay? Our ending pressure, we don't have an ending pressure, so that's what we're going to solve for. And our ending volume is 0.3 liters, okay? So our formula is P1V1 equals P2V2. Now we're solving for P2, so we have to get P2 on one side of the formula by itself. So a little refresher course of some basic algebra. All right, if we divide each side of the formula by V2, my V2's cancel out, so that gives me P2 is equal to P1V1 over V2. Now all I have to do is just plug in my numbers, right? I've got, let's see, my first pressure is 500. Let's erase that and fix that there. Sorry about that. Our first pressure is 500 kilopascals. Times my beginning volume is 1 liter, and then I divide that by my ending volume, which is 0.3 liters, and that gives me 1,666.67, so we'll round that to 0.7, and we're calculating for our second pressure, sorry, not volume, we're calculating for P2, so my unit of measurement has to be kPa, because my liters cancel out, so I'm left with kPa. So it's pretty simple. It's just a matter of knowing what each pressure and each volume is and putting that into your formula and manipulating the formula so you're calculating for the right variable. All right, let's try another one. Here we have a balloon of helium, occupies 44.98 liters at 9 kilopascals. What is the new volume if the pressure drops to 4 kilopascals? All right, so let's check this out. So again, P1, V1, P2, V2. My beginning pressure is 9.0 kPas. My beginning volume is 44.98 liters. My ending pressure is 4.0 kPas. And my ending volume, that's what I'm solving for. So P1, V1 equals P2, V2. I want to solve for V2, so I'm going to get rid of my P2 on that side. So here what I'm left with is V2 equals P1, whoops, got a little excited there, P1 V1 over P2, okay? So my ending volume is going to be 9.0 kilopascals times 44.98 liters, and I'm going to divide that by 4.0 kilopascals. All right, so my kilopascals cancel out, so I know that I have to have liters as my unit of measurement. All right, let me punch this in my calculator. So let's see, 9 times 44.98 divided by 4.0 gives me 101.2, and liters is my unit of measurement. All right, so that's Boyle's Law. All right, so not too bad. Just again, it's making sure that we have our units of measurement, knowing our units of measurement, knowing what numbers to put in the right place in the formula, and there we have it. So we'll practice this in class tomorrow. All right, see you tomorrow.